If you traveled back 340 million years to the Carboniferous period, you would witness this breathtaking scene. Lobe-finned fish leaving the water and beginning to climb onto land, about to establish an extraordinarily glorious dynasty. Looking across the land, you'd see nothing but lush vegetation, with warm and humid prevailing climates, creating countless swamps and rainforests. The first life forms to venture onto land were arthropods. Their incredibly hard exoskeletons might remind you of those trilobites from the ocean depths. This enormous creature before you is called Arthropleura, the largest millipede in Earth's history. Measuring 2.5 meters long and over half a meter wide, you needn't fear it despite its terrifying appearance, because Arthropleura was actually a herbivore. As long as you don't disturb it, it generally won't be interested in you. As one of Earth's earliest dominant creatures, Arthropleura had virtually no natural predators at that time, which meant it could focus its energy elsewhere, like finding a mate. Unlike modern animals seeking partners, Arthropleura faced significant challenges in finding suitable mates because they were eyeless. Their world limited to what they could sense through touch. Bumbling around was inevitable in their endless fern forests, where encountering a potential mate was like winning the lottery. Yet the charm of life lies in its infinite unpredictability. Sometimes a wonderful chance encounter can create beautiful accidents. These creatures might frighten many students, but we should try to appreciate the most primitive, pure charm of life. The high oxygen concentrations not only created giant millipedes, but also enormous dragonflies as large as eagles, a phenomenon closely related to their respiratory systems. Now let's examine human ancestors. The theory that humans originated from fish has been confirmed, more precisely from lobe-finned fish. These fish had highly developed paired fins strong enough to support their body weight, and they gradually transitioned from gill breathing to developing primitive lungs. Various specific conditions prompted lobe-finned fish to venture onto land, but this particular group arrived too late. Other members of their kind had already made the transition and evolved more advanced adaptations, meaning most of these latecomers became easy prey the moment they reached shore, completely defenseless against creatures like Proterogyrinus, 3-meter-long early amphibians whose limbs had successfully evolved from fins over millions of years. By this time, amphibians had firmly established themselves on land, with the only drawback being their need to inhabit swampy areas as their skin required constant moisture to survive. With few land animals yet evolved, the abundant vegetation created this high oxygen era. However, excessively high oxygen levels weren't entirely beneficial. A single spark could trigger devastating disasters, with frequent wildfires limiting plant expansion. Meanwhile, Earth's continental configuration underwent dramatic changes, with land masses gradually converging over time to eventually form the supercontinent Pangaea over the next 2 geologic periods. This created extremely dry inland climates, causing most swamps to disappear. The dwindling water sources forced some amphibians to evolve further. Previously laying eggs in water, they now began laying them on land, with the egg membrane gradually hardening into shell.